Good morning, everybody. Welcome to this computer science class 12. In this computer science, you have total 9 chapters. 4 chapters are on software, balance 5 chapters are on hardware. So we'll start one by one. Your first chapter of first paper, that means software domain is OS, that is the operating system. Now, what is nervous system of a human body? Let us think that way. If a human body doesn't have any nervous system, whether the person can live, whether he can do his normal work in his life, no, he cannot do, because his nervous system is not there. So nervous system is the system that keeps the man to perform his activities. Similarly, operating systems of a computer is something like that. Nervous system of a human body. Without operating system, the computer hardware is nothing like toys. Computer cannot perform any job without operating system. So there is one layer of software around the computer hardware. That is the operating system. Let us see in detail. This is our operating system. In the diagram, this is the operating system, and this is the hardware. उसके ऊपर है operating system. Above that is the application program. Application program means what are the programs you develop, whether it is in Visual Basic or C++ or it is in .NET, anything that is on this layer above the OS. उसके ऊपर है finally is the use. So these 4 components are there in a computer system. Okay, so we can tell a computer system can be roughly divided into 4 components: the hardware, the operating system, application program, and users. OS is a program which acts as an interface between user of a computer and computer hardware. So this is the user, this is the computer hardware, it is acting as a basic resources of a computer system provided by its hardware, software, and data. OS provides the means for proper use of this in the operation of the computer system. So you have a hardware, you have a software, you have data also. Now how it will work? OS helps to function in such a way that you can work on using these resources, hardware. So the services of OS, there are a lot of services it does. इस सब सभी को grouping किया है. It can be grouped into 3 major categories. They are information management, process management, and last one is memory management. So what OS does, all these activities are grouped into these three. One is IM, one is PM, and one is MM. IM refers to a set of services used for storing, retrieving, modifying, or removing the information on various. What do I do in computer? We create a directory, we create file, we create data. Data is written in the file. Data is removed from the file. File itself is deleted. All these activities is done. All these activities are controlled by IM services of OS. So create a directory, create a file, open a file for read, write, both, then close the file. These activities. Read data from file to buffer, write data from buffer to file, because we have to use buffer. Through buffer only everything is carried out. Move file pointers, one file to another file. All the activities is managed by IM module of operating system. Now process management, PM services. This is another second services of the OS. What is process? Process is basically the program in computer. Running program in computer is called process. What is program is loaded in the memory for execution, that is a process, that is called process. So OS schedules all processes. Suppose we have multiple programs are running. OS schedules all processes, execute them one after another, and terminate them. When job is over, it terminates the job. That also done by PM services of OS. In a multiple user environment, there are multiple users and multiple processes. One CPU executes program of all the users with coordination with PM services of operating. What the services it does, what the job it does with PM is it creates child processes identical to the parent processes. Process means the program running in the memory. Change priority of process, block a process, ready for execution. Block a process means stop the processing, dispatch a process, suspend a process, resume a process, delay a process. Finally, it terminates a process. These are the jobs done by process management service of OS. We'll see all these things in details next subsequently. Next, the third one is the memory management. So, because when you use computer, your data, your your programs all are stored in the hard disk. But for execution, everything has to be loaded to the memory, primary memory of the computer. Without loading, nothing can be performed. So when you're loading your program or data to the memory, there are multiple programs will be there, multiple data will be there. Memory needs a proper management. How much memory has to be allocated to which process? And when one process is over, how the memory has to be released? Other process. This is the job of memory management services of OS. So it allocates a chunk of memory to a process, free chunk of memory from a process. Memory management services keep track of memory and deallocates it to various processes. OS gives a list of free memory locations. Before a program is loaded in the memory disk, The memory management services of OS checks the free list, allocates the memory to the process, and updates the list of free memory. Because something was already free, the list of the free memory, what is sent to some process, so that it removes them, so it updates the list of free memory, and memory allocates the process depends on the program. How much memory is allocated to which program, which process, that depends on the program size. A big program, so it needs big memory, more large memory. Okay, that was the, so we have learned that the basic three services are done by operating system. One is information management, one is process management, and third one is memory management. Now we'll see the operating systems available in the market nowadays. What are the operating systems are available? First operating system that came is MS-DOS in 1981. It is developed by Microsoft for IBM PC. MS-DOS or PC-DOS. Microsoft DOS. DOS means this operating system. PC-DOS or MS-DOS. They are developed by Microsoft. This operating system has a lot of limitations. Mostly it was dealing with text data. So after around 10 years, Microsoft developed Windows 3.0. Windows 3.0 is a GUI OS. That means graphical user interface. In DOS system, everything has to be typed in. All command has to be typed by the user. But in GUI based OS, we can use mouse. There are a lot of icons will be there. By clicking the icons, we perform our task. Then in 1995, Microsoft developed Windows 95, user friendly. Subsequently, it is upgraded to Windows 98. So this is the motamoti history of Windows operating system. Now the Windows 98. What is the feature of Windows 98? It is a single user multitasking OS. That means one person only can use it. But it is multitasking. Multiple tasks it can perform. Navigation is easier through mouse. By click can be opened. It supports USB standard. It was not there in earlier versions of 98. Plug and play of new hardware is possible. So if you put in new hardware, attach in the USB port, it will start working maybe about in 2-3 minutes after installing its drivers. Now digital camera can be attached and it supports DVD, supports movie, it supports FAT32 systems to store file more efficiently and save hard disk. Connection to web is simple. Microsoft Outlook Express is used for email. You might have used Microsoft Outlook for email purpose. It consists of program manager, file manager, and control. Windows 98 का जो activities है, these are grouped in these two. These three: file manager, this is program manager, file manager, and it has a control panel. So whatever we see, 98 is a single user operating system. Microsoft subsequently developed Windows 8. Windows NT is a full-fledged portable OS like Unix. This is a multi-user, it's not a single user. So multiple people can work on a machine running by Windows NT. So it is a multi-user, it is multitasking and multi-threading also. What is multi-threading, that we will see in our next slides. So it is a multi-user, multitasking and multi-threading. Multiple applications can run fast. Time slice is given to each task by OS. See, when multiple processors are there is one single CPU. So how it will work? CPU time is divided based on some algorithm, and that time is given to the each process. So that is called time slice is given to each task. One time slice is over, next task starts. So once some second, in terms of second, some timing is given to process 1 to the CPU. CPU will do the job and it will come out from the memory. Process 2 will go inside the memory. So this way times are divided among the processes. In a multi-threading task, a task can be subdivided into small and called threads. So we have seen multitasking is multiple tasks is performed by the CPU. Now one task again further subdivided to small part. That's called threads. So in multi-threading, tasks can be subdivided into smaller units called threads. Now this, so one task is divided into multiple threads. So this there different threads can be done parallelly by multiple CPU. We have multiple CPU. Different threads can be scheduled and executed independently. So one task is divided into threads, multiple threads, and all those multiple threads are executed independently. So this job is done by Windows NT OS. So suppose you have a multiple CPU. That is, if you have multiple CPU in a computer system, then Windows can schedule the task to any CPU. It has the capability of assigning the task to any of the CPU. If you have a multiple CPU, you have a multiprocessor system. Windows NT is a 32-bit operating system. Suppose NT was long file name. Initially, file name was limited to 8. Now, NT supports is a long file name. Now, what are the major modules of the Windows NT? Major 6 modules that forms executive are object manager, process manager, virtual memory manager, security interface monitor, local procedure call facility, and IO. Windows 32 subsystems handles all the users diagram how it works. So this is the Windows NT block. Okay, this is your server, I mean hardware. This is the kernel. Okay, above that, the OS is the kernel of the OS. OS, this is the object manager. This is security reference monitor. This is a process manager. This is a virtual memory manager. Local procedure call facility. These are network drivers, device drivers, manager, file systems. You see here, these are the users. Now in NP system, you may have multiple users using multiple OS. Somebody using OS 2, somebody using Windows 16-bit, somebody using Windows 2-bit. Somebody using MS-DOS, somebody using PO6. PO6 means other operating systems other than these operating systems. Now here is the login procedure. When you log in, that's security subsystems, authentication package, then security add-on database. So this is the block diagram. I mean the pictorial display of Windows NT, how it functions. So we have seen this Windows, we have seen MS-DOS, Windows 3.0, the 95 and 98. Finally, we have seen NT also. This is all our Microsoft OS. Now you see non-Microsoft OS. Linux, for example, Linux. Linux is a 32-bit OS developed in, okay. It is free software. People can copy it, modify it, use it in any manner. And this thing you cannot do in Windows OS. In Linux you can do it. Main body of Linux systems are kernel, system libraries and system utilities. The multi-user multitasking OS, the full set of UNIX compatible. So UNIX is another operating system. Linux uses, all the tools of compatible tools of Unix are available in the Linux. Initially, Linux was developed for PC, but run on a wide variety of platforms. File system in Linux obeys Unix semantics. Unix has some own semantics. Same file systems are used in Linux also. Linux can run on machines having 4 MB. This is a minimum 4 MB RAM. Okay, you see, we have seen that what are the three category of OS. One is information management services, IM services. One was process management services. Third one was memory management services. Now we see details of these three services of OS. Now the first of that is IM services, information management services. Information management services, IM services can be again further divided into two. One is file system, one is device driver. Now what is this file system? A file is a collection of related information. It may be data or programs. It is a sequence of bits, bytes, lines, or it is a name referred by its. So each file has a name. Now when we refer a file, we refer by file name. And file contains information like it contains programs, it contains the earlier file system were tape based. I think you might have not seen that tape based system. When there is a tape based system, it's called third generation computer or second generation computer. They used to use TOS. TOS means tape system. So earlier system was tape based. Tapes are used for data transport between machines or for data backup. What used to do? There is a system with a hard disk also. That data is to copy it from one tape to another tape or taking backup. Transferring data from one tape to another, one machine to another machine. We used to use tapes. Now, disk-based file system has replaced tape-based file system. When disk came, hard disk, the tape-based systems have gone away. So nowadays you can't see any tape-based computer. Any more computer you see, I think you cannot imagine also there was a tape-based computer system. Now everything are disk-based. Now these file system made disk-based file systems. In the files, the disk are records. So the records, all the data, all the programs, the hard disk stored in terms of blocks. File concept is implemented by OS. Systems calls are provided to create, write, read, rewind, and read. Rewind basically is using in tape environment, rewinding the tape. So if this is a file, using a hard disk, OS does this mapping, file to hard disk. File system means basically what it does. What it gives a file name is data is written in the file. That is read from the file. That data is written on the file. And finally, the file can be deleted. These are the activities in the file system of OS. So next, for each of the file system operation, file name, directory entry, and execution are the parameters. So whenever you look at a file, you should know the which directory file is there, what's the file name, and it gives the parameters like location. Information like file name, file type, location, size, protection details, usage count, and stamp are stored in the directory keeps us so many information. File access mechanism like sequential access or direct access are performed by OS subroutines. Subroutine means there are small routines are there, programs are there. Those are executed your file. For effective utilization of disk space, allocation of disk space, free space management are performed by three methods are used for allocating space are contiguous, linked, and indexed. So you see one thing, when there is a disk, one hard disk, there will be multiple files. Now how we allocate the disk space to your to a file? File may be program or maybe data, whatever it may be. How it will allocate the spaces? There are three categories. Three methods are there. One is contiguous. Contiguous means the continuous blocks are given. One is linked. Linked, we'll see how it means how that here it doesn't give the continuous space to a file. One block is given and that block is linked to the second block in some other location. Not necessarily that it is a contiguous. And third one is a next. We'll see all the in today. All the So this is a contiguous allocation. You see, these are the files. Count is a file, tr is a file, mail is a file, list is a file, f is a file. Now this is the where the located location is location. The directory have this information. The count starts from 0 block. And length is 2. So these two are the your count file. Since the TR file starts by 14 is a 14. 14 and it's 3 block. So 14, 15 and 16. So it's closed there. Similarly, mail is here. Mail is a 96 length. 6 blocks. 1, 2, 3, 4, 5, 6. Last one is the F. F is the file and it starts at 6. This is 6 and 2 blocks. So you see, here file cell space is given continuation to blocks. Okay. This is the one way of allocating this space. So this job is done by file system of OS. This is the linked allocation. What it does, any file, this for example, zip is a file. It gives the start block and give the and how other blocks are linked? They are linked. Start block is 9. This 9 is 9. Okay. It gives the address of the next block. Next block is 6. Suppose that is 16. So it will be 16. So it will come here. This is next. It will give the next address 1. So this is second 1. It will give 10. This is a 10. It gives 25. It will give the end. So this is a file allocation using linked allocation. See, it is not possible to provide contiguous disk spaces to any file. Okay. It wastes disk space. So wherever there is a free blocks are there that are used through links. This is the example of linked allocation. The job is again done by file system of operating system. The last one is the index allocation. Here it gives the index. These are the indexes. First block is in 9, then next go to 16. Instead of linking, they keep in the one place. These are called that is called index. So this is the index for file system. This is the index where it goes on by one. In this sequence. This is the index. So we have seen contiguous allocation. We have seen linked allocation. Indexed allocation of these spaces. Now there is the other aspect of information management process. We have seen IM processor does two major jobs. One is a file system, as device data. File system we have seen. Now let us see what is device data. Device data means whenever a device adds in a system, that a device has to work that device. We need a small program, small software. That software, small software, that thing required to operate that device is called device driver. Device driver for that equipment. Okay, that is also done by IM process of managing the device drivers also managed by IM of IM process of operating system OS. Okay, each IO devices, input output devices, has its own characteristics. It may be mouse, it may be monitor, it may be a web camera, it may be modem, anything. It may be printer. So each IO device has its own characteristics, requiring special subroutines. Subroutine means small programs. These special subroutines are called device driver. Each different type of device has its own driver. For example, terminal is a device with keyboard as input and APU as output. It has its own driver. You don't give the proper driver to the terminal. Terminal will not work properly. It will misbehave. Your display may not come correctly. Your keyboard keys may not work correctly. So proper driver for that terminal will be required. So this is the second aspect of IAM process of operating systems. So IAM process of operating system we have seen in detail now. Let's see the next of the next. And next is the process management. Process management means process. We have learned that process is nothing but the program that is in computer, which is loaded in the memory. So a program loaded in main memory for execution is called a process. In multi-user system, many users sit at their respective terminals and execute the same or maybe multiple users are executing same programs, or they may be using different programs. But computer तो एक ही है. Then we have multi-user system. It can handle multiple users. Now, handle means what? Who will manage all these things? PM of OS enables CPU to switch from one user to another and allocate CPU. Earlier also I mentioned a CPU, if you have a single CPU, its time has to be sliced. Its time has to be divided small portion into seconds, and that times are the multiple programs. That times as so it says the management of operating system enables to switch over one user to another user. So this job process management does the job of the PM of OS, allocating CPU times to the different programs. So in multiprogramming environment, multiple programs will run on the single computer and that is executed by one single CPU. Suppose you have a single CPU. In any process, any program, it is the activity of the programs can be divided into two categories. One is IO bound, one is CPU bound. IO bound means that some program you may need time has come to it has to print some document. Time has come to read some record. IO activities. And CPU activities means CPU bound means when CPU executes it. It's some computation. Computation has come, then CPU has to execute it. So in multiprogramming, we can run two processes simultaneously. Process 1 waits for CPU executes the. If process 1 waits for IO, CPU executes process 2. So one program is waiting for IO. It is not ready, so it's waiting for that. So CPU you cannot keep idle. CPU will take the next process for execution. Okay. CPU cannot remain idle as long as there is some process to execute. Switching from one process to another. Switching from one program to another is called. In order to manage switching between processes, OS define three process states: running state, ready state, and block state. So you should understand OS should, I mean, define the process in three categories. What is process? So it is running, or it is waiting for something, or is it blocked? Now, what is this? Let's see the what is multitasking. A process consists of multiple tasks. Okay? These multiple tasks can run simultaneously, like multiple processes run simultaneously by a multitasking improves the CPU. So one program is having multiple tasks. All tasks can run simultaneously by multi-user OS. It cannot be done by single user OS. Multi-user OS, multi-user OS, the multiple tasks simultaneously. So CPU is used effectively. So that is called multitasking. In multiprogramming environment, CPU time is shared by all the programs for a short time. This is referred as the time sharing computing. Multitasking is nothing but time sharing computing, time sharing of CPU. Now we'll go for, so we have seen that what is IM, what is EM, what is management. Now we'll see the memory management. This is one of the major complex issue, managing the memory, because when some multiple programs will run, it will occupy memory location. Now how that memory will be allocated, how memory will be protected such that it should not be overwriting. So this job is, is done by memory management services of operating system. The process of OS performs the following task: keep track of all memory locations, free and allocated. Memory, what is the free area, what is the allocated area? That is, it has to keep a track of that. Decides memory allocation policy, which process should get how much memory. So this is also gives priority. My job has to be done first. So it gives us more memory. It gives priority by OS. Use various techniques and algorithms to allocate and deallocate memory. Different algorithm it uses for using the memory. When job is over, so it has to be removed from the memory. Memory has to be freed. That job also done by MM. MM has a lot of activities. So this is a pictorial display of memory management of MS-DOS single user. This is the kernel. This is the command interpreter. This is the process. The free memory. This is the memory fixed. This is the memory. Allocated like this. Single user OS like MS-DOS has a command interpreter. Gets invoked when computer starts. Okay. The OS loads program into the memory and assign as much as memory is possible because there is no multi-user. So जितना memory possible है assign करो. This instruction pointer and execute this program. When program is terminated, it is moved from the memory. Kernel of OS provides basic OS services. Basic services of OS is done by kernel. Now there is a concept of partitioning, memory partitioning. Now memory when memory has to be given to multiple, memory has to be partitioned. So partition करना पड़ता है. Now the partition can be done in two ways. One is fixed partition. One is fixed partition means they are fixed. That is when memory systems it's installed. That time it's fixed. They decide the memory what is the partition of the memory. That's called fixed partition. Partitioning means dividing main memory into various. Partitioning means dividing main memory into various sections or partitions. Partitions are of different size, but once decided, they cannot be changed. So called fixed partition. Okay, so this is always allocates this partition to processes. System कभी भी कुछ program आ गया, it allocates this partition to the fixed partition wastes memory and limits CPU utilization and degree of multiprogramming. Because if fixed, suppose you have fixed partition of um, 50 KB, but your program needs only 10 KB. So 90 KB will be waste of that fixed partition. So fixed partition wastes memory and limits CPU utilization. Multiprogramming. So it is some limitations on the multiprogramming environment. Variable partitions solve this issue. There are number of partitions and the sizes are variable. In fixed partition, they are fixed at the time of system generation. But in variable partition, it is not fixed. Dynamically, partition is done dynamically. Size is decided. The variable partition memory at any point in time, any given time, any partition can be free or allocated to some. Now, the virtual memory. Virtual memory is a technique which allows the execution that may not completely in memory. Some part of it is can be on the disk. So you can say you have a memory, limited memory, but your program size is more big, larger. So you cannot load the complete program in the main memory. Part of the program they keeps on the hard disk. That portion of the hard disk called memory. Whenever is required, that program is being from the hard disk and put in the load in the main memory. This is swapping. And swap out means something removed from the main memory and put back to the hard disk. This type of arrangement is done when you have a big program but memory is smaller. This is concept of virtual memory. Main advantage of this is that these programs can be larger than the physical memory. A program is divided into pages. Some pages are loaded into memory while rest remains on disk. Whenever required, they are loaded in memory on the disk. So the next point to discuss is GUI. GUI means graphical user interface. What happened when that originally computer came? I mean, that time computer was not available to everybody. It was available only to the scientists or some special people who are computer literates. So while using computer, they used to use some commands. I mean, it's called cryptic commands. I mean, it has its own grammar, some special characters, sometimes a lot of, I mean, complicated commands are there. They used to use that because it was computer was used by only literate people. Okay, that set of commands are cryptic commands, and you are supposed to remember all those commands while using the computer. But subsequently, when computer PC has come, this is personal computer, it has gone to the all people, whether you are computer literate or you are scientist or non-scientist. It is gone for commercial uses. When it is gone for commercial uses, then all these scripted commands, how it will work? It cannot work. So what was required at that time was requirement was to have a good interface between the users and computers. So from that the concept of GUI has come. So through now all the computers uses GUI, graphical user interface. They use mouse for doing a lot of jobs. One mouse click means it has a lot of cryptic commands inside that user does no user they doesn't know. They don't know what are the commands. One mouse click they open the file. One mouse click they close the file. One mouse click they delete the files. One mouse click they move the file from one place to one folder to another folder. So there are so many commands are there inside. It's not supposed to known by the users. So that's why the GUI concept has come to make interface easy. Okay, let's see the now the next. Okay, so this stops our the session on operating systems. What we have learned, what is operating system, what are the functions of services of operating systems, what we do in operating systems. So remaining part of the operating systems, I think 3-4 slides are left out that we will discuss in the next session. Okay, we'll close the session now. Okay, thank you very much.